Here's a triangle. How much space does it take up? Simple question, with something hiding inside it. How big compared to what? Measuring is always comparing. You never measure a thing on its own. You measure it against something you choose. So, our triangle is how big? Next to what? There's one obvious choice, the box it sits in. It fits snugly. Just wide enough, just tall enough. So, here's a question we can actually answer. How big is the triangle compared to its box? Now, from the peak, drop a line straight down. One cut, and the whole thing falls into two, a left side and a right side. So the box is the left plus the right. Take the left side on its own. The triangle's edge runs straight across it, corner to corner, a diagonal. And a diagonal splits a rectangle into two identical halves. The empty piece is a perfect copy of the filled one. So this side is that piece twice. The right side, its own diagonal, the same clean split, twice its piece. Now put the two pieces back together. This one plus this one. That's exactly our triangle, so the box holds our triangle twice. Turn that around, and there's the answer. The triangle is half of its box. Exactly half. But hold on. What if the peak leans out, right past the edge? Build the box the same way, and the triangle spills straight out of it. Is it still half? Here's the move. Stretch the bottom out to under the peak, and drop the line there instead. Now, our triangle, plus this extra flap, together they make one big right triangle. And that big triangle has an enclosure of its own. Its long edge runs corner to corner, a diagonal again, which means it fills exactly half of it. Same story for the flap. A little enclosure around it, crossed corner to corner, so the flap fills half of that one. Now take the flap away. What's left is our triangle. Half of the big one, minus half of the little one. Half of one minus half of the other is simply half of what's left. And what's left is exactly the box we started with, so even leaning right out, still half. Upright or leaning, and everything in between. One box, and a peak that can sit anywhere along the top. Slide it into the corner, or right out past the edge, the one we just checked. The box never changes, and every single one of them is half of it. So what is that box? This much across times this much up, the base and the height, which makes our triangle 1/2, base, times height.